Before understanding Pulsus paradoxes or the pathology behind Pulsus paradoxes, you need to know the normal physiology. The normal physiology is that during inspiration, the systolic blood pressure it decreases. How? During inspiration, the intrathoracic volume it increases and the intrathoracic pressure it decreases. So the pressure inside the right atrium also decreases. As a result, lots of blood gets sucked into the right atrium. That is, there is increase in preload. This lots of blood then flows into the right ventricle. Inside the right ventricle, this lots of blood is gonna push against number one, the free wall, and number two, the interventricular septum. Since the free wall is fixed with the pericardium, it is the interventricular septum that gets affected. That is due to the push by the lots of blood in the right ventricle, the interventricular septum gets slightly pushed to the left side. As the interventricular septum gets pushed to the left, the space inside the left ventricle decreases. So number one, there is decrease in the cavity size of the left ventricle during inspiration. Number two, the decrease in pressure is not just in the right atrium. The pressure decrease is also in the lung. As a result, the lung it holds blood with itself. So there is less filling of the left atrium. Since there is less blood in the left atrium, there is also less blood in the left ventricle. So point number two, less filling of the left ventricle. So during inspiration, two things are happening. Number one, there is decrease in the cavity size of the left ventricle. And number two, there is less filling of left ventricle with blood. As a result, there is decreased cardiac output and a decrease in systolic blood pressure. Normally, the decrease in systolic blood pressure is by less than 10 mm of Hg. It is only when in certain pathologies that the systolic blood pressure decreases by more than 10 mm of Hg do we call it Pulsus paradoxus. So the fact is that Pulsus paradoxus is not actually the measurement of your pulse, but instead the measurement of your blood pressure, more specifically the systolic blood pressure. Okay, let's revise what I have said just now. Physiologically or normally, this is what goes on. Normally, with inspiration, the intrathoracic volume increases and the intrathoracic pressure it decreases. As a result, the pressure inside the right atrium also increases and the preload into the right atrium increases. So there is lots of blood inside the right ventricle which pushes the interventricular septum to the left, which results in decreased cavity size of left ventricle. So that's number one. This is number one. The decrease in pressure is not just in the right atrium. There is also decrease in pressure in the lung. As a result, the blood, it retains blood. It holds blood in itself. So there is number two, less filling of left ventricle through left atrium. So less filling of left ventricle. Due to both these reasons, that is decrease in cavity size of the left ventricle due to push at the interventricular septum and due to decreased filling of the left ventricle due to holding of the blood by lung, you get a reduced cardiac output and a reduced systolic blood pressure, which is by less than 10 mm of Hg. While in Pulsus paradoxus, what you get is the same thing. It is nothing but the exaggeration of normal physiology. So instead, in drop in systolic blood pressure by less than 10 mm of Hg, the drop in systolic blood pressure during inspiration is by more than 10 mm of Hg. It's by more than 10 mm of Hg. Pulsus paradoxus is seen in pathologies associated with cardiac causes and non-cardiac causes. The cardiac causes are number 1, cardiac tamponade, number 2, constrictive pericarditis, and the non-cardiac causes are number 1, acute exacerbation of COPD, number 2, acute severe asthma, number 3, tension pneumothorax, and number 4, pulmonary embolism. The graph would look something like this. So this is your normal pulse waveform, right? The peak represents the systolic blood pressure. As inspiration goes on, the systolic blood pressure, it falls. And I've just mentioned you the 2 reasons why there is decrement in cardiac output and a fall in systolic blood pressure. This takes place normally as well, physiologically as well. It is only when the drop in systolic blood pressure is more exaggerated by more than 10 Hg, we call it pulsus paradoxus. The question is, so in fact, pulsus paradoxus is not the measurement of your pulse, but the measurement of your blood pressure, more specifically the measurement of your systolic blood pressure. Then where's the paradox here? What is the paradox? Here's the paradox. Paradox. Okay, let me just explain it. I don't really have to write it. You will understand it from explanation. Okay, this is the paradox. During pulsus paradox, the contraction of the left ventricle is weak due to fall in systolic blood pressure. There is massive fall in systolic blood pressure during inspiration. See, in pulsus paradoxus, during inspiration, the fall in systolic blood pressure is by more than 10 mm of Hg. And at this point, the contraction by the left ventricle is not strong enough to produce a pulse. So, when you get a patient with pulsus paradoxus, you auscultate the heartbeat and palpate the radial pulse. During inspiration by the patient, you will find that you are able to hear the heartbeat, but you are unable to feel the pulse. That is the paradox. The paradox is that even though there is heartbeat, there is no pulse. Got it? See, there is a patient with pulsus paradoxus. You go and auscultate his chest for heartbeat and palpate his radial pulse at the same time. During inspiration, okay, you are able to hear the heartbeat and you are able to palpate the pulse. But during inspiration by the patient, the systolic blood pressure decreases by so much so that the contraction of the left ventricle is not strong enough to produce pulse. So at that time, you are able to auscultate the heartbeat but unable to feel the pulse. That is the paradox.